Assalamu alaikum everyone. I am Nighat Fatima and today I am going to do the experiment of Zener diode. There are the characteristics curve of a Zener diode and also we will find its voltage breakdown current. It is a special type of diode that allows current to flow in both directions, but mainly it is used in reverse bias. It has a unique property. When the voltage reaches a certain point called the Zener breakdown voltage, at that time the diode starts to conduct the current in reverse bias and the voltage across it remains almost constant. This is our apparatus of Zener diode and this is voltmeter positive and negative. This is our milliammeter positive and negative. This is our Zener diode and this is the N terminal of Zener diode and it is our P terminal of Zener diode. It is our regulator, voltage regulator. This is our resistor. These two are positive terminal and these two are negative terminal of DC output. This is our circuit diagram and according to this we will connect our circuit. Here I am connecting positive terminal of diode with negative terminal of a battery. Then positive terminal of a battery with positive terminal of a milliammeter. Then negative terminal of a milliammeter with negative of a diode. Next, positive voltmeter, positive terminal of a voltmeter with positive terminal of a battery and negative terminal of a voltmeter with negative terminal of a battery. You can see three Zener diode of 5.1 volt, 8.2 volt and 12 volt. But I am connecting here it with 5.1 volt, but we can connect it with 8.2 volt and 12 volt also. Our circuit is completed and now I am going to supply the current in it. Now we are going to take the observation. You can see when the voltage is at 0, current is also at 0. When we are increasing voltage at 0.25, the current is still at 0. Further increasement in the voltage, current is still at 0. When we are increasing voltage continuously, current is still at 0. When the voltage reaches at 4.25, the current is 0.25, means the increasement in the current is shown. When the voltage is 5.25, the current is 0.75. When we are increasing voltage, further increasement in voltage, you can see the current is also moving. When we are further increasing the voltage, you can see the sharp increasement in the current. Here is our observation column. You can see when the voltage is 0, current is also 0. Here up to 4.5, the current is still 0. But when the voltage is 5, there is little increasement in current also. Like this, we want to take 10 readings. If we are going to take the more reading, the errors will decrease. Now we are going to find the least count of voltmeter. How we are finding it? The range of voltmeter we are dividing with the total number of division in it. Here the range of voltmeter is 15 and the division in between this is 60. So least count of our voltmeter is 0.25. We are going to find the zero error of voltmeter. Before connecting its needle is at 0, so our zero error of voltmeter is 0 itself. Least count of milliammeter. Here we are finding range divided by total number of division in it. Here our range of milliammeter is 15 and division in it will be is 60. So least count of milliammeter is 0.25 itself. Before connecting it, the needle of ammeter is at 0, so the zero error of milliammeter is 0 itself. Least count of voltmeter is 0.25 volt, zero error of voltmeter is 0 and least count of ammeter is 0.25 ampere and zero error of ammeter is 0. Based on the observation column, we are plotting the graph. In x-axis we are plotting voltage and in y-axis we are plotting the current. Here in x-axis we are taking the reading from 0 and then 0.5, 1, 1.5, 2 like that. In y current reading we are taking 1, 2, 3 and 4. Up to 4.5 there is no change in the current, but from 4.5 it is slightly increases, then suddenly it get increased. This graph we are knowing the breakdown voltage, and our breakdown voltage is this because here the current starts to increase sharply, though, so our breakdown voltage is this point 4.5. Result of our experiment is at a specific point across the voltage called Zener breakdown voltage, the diode starts to conduct current and the voltage across it remains almost constant, and the breakdown voltage is 4.5. Voltage current graph is drawn. This is my experiment and I have found the graph and observations. Here I am signing off. Thank you.